You already know the definition of an acid. It's a proton donor. You already know the definition of a base. It's a proton acceptor. And when we first gave you what a base was, the most common base is OH. So the OH and the H combine to make water. But today we're going to give you a new definition, and that concerns what is a conjugate acid-base pair. Well, it's an acid-base pair that differs only by an H+. I'm going to go through this first example very slowly, and I'm going to show you what you need to do, and then on the other examples we'll go a little bit faster. So, directions. On the left side of each example, label the acids with an A and bases with a B, then show the proton that is donated. Well, if we look on this side of the reaction, which chemical, this one or the water, is going to donate the hydrogen? Well, to figure that out, let's pick one of them. Let's look at the first one. What you need to do is look at it and then look on the other side and notice that on this side, the H is gone. So this must be the acid. And if you look at this one, H2O, oh, it has another H on it. So that must have accepted the proton. So this is the acid, and then this is the base. Then we want to show the proton that's donated. So we'll circle the H and show it with an arrow, and the base is accepting the H. Now, in the direction on the right side of the example, label the conjugate acid with a Ca and the conjugate base with a Cb, then show the proton that's donated. Now, as you can see down here, this is at equilibrium. So the reaction is occurring in the opposite direction also. So what you do is you look at one of the chemicals, pick one, so we'll pick H3O, then look on the other side. On the other side, this H3O is now H2O, so it lost an H. So this must be the conjugate acid, because it will lose an H to the base and change into water, and then this gains the H and changes back into CH3COOH. So this is definitely the conjugate acid, and this is the conjugate base. Then we'll show the proton that's being donated. And then our final direction, draw a bracket between each conjugate acid-base pair. The acid-base pair only differs by an H. If you take a look at H2O and H3O, there's just a difference of an H. So this would be a conjugate acid-base pair. And then on the other chemical, CH3COOH, and over here, it's missing the H, so they only differ by an H. So these two are the conjugate acid-base pairs. Now in our next example, auto-ionization of water, it's obvious you can pick either one of these as being the acid or the base. So I'm just going to pick the first one as the acid, and the second one as the base. I'm going to show the proton that's being donated. Then on the other side of the equation, which one's the conjugate acid and which one's the conjugate base? Well, you've got to pick one, and if it's going to go reverse, this H3O now becomes H2O. So this is going to lose an H, so this must be the conjugate acid, and the other one is the conjugate base. And we'll show the proton that's donated. So this is the conjugate acid-base pair. In the next example, ionization of phosphoric acid, well, we tell you that this is an acid, so we can label that as an acid. But if you didn't know that, this is H3PO4, this is H2PO4. So it lost an H going from here and ionizing into this ion. So this is the acid, and then this is the base. Then we'll show the proton that's being donated. Then when we go to this side, this H2PO4, when it goes reverse, changes to H3PO4, so it must gain an H. So this must be the base, and this H3O turns into H2O, so this must be the acid. So we'll label them. That's the acid, H3O, and then that's the base. We'll show the proton that's being donated. And then the conjugate acid-base pair, we've got this acid, H3O, H2PO4. They only differ by an H, and these two only differ by an H. So those are the conjugate acid-base pairs. The new topic here, or the new concept, is conjugate acid-base pairs. So just let's review like on this one. H2PO4, and this is now HPO4, so this differs only by an H. Let's define amphoteric. Amphoteric is a substance that's capable of acting as an acid or a base. The question at the bottom is asking, using all the equations above, list the substances that are amphoteric. All right, so let's look above. What we're trying to do is kind of look at which ones act as an acid and a base depending on where they're at. So if you take a look here at water, it's obvious. Water is acting as an acid here. It's acting as a base up here. It's acting as a base right here. It's acting as a base over here. It's acting as a base right here. And it's acting as an acid over here. So it's obvious that water in these 5 examples can act as an acid in one case and a base in another. So water is one of the answers. The other one is H2PO4 because it's acting as an acid here, and over here it's acting as a base because it's accepting this hydrogen. So that's acting as an acid or base depending in these 5 examples. So 2 answers to the amphoteric question.